Process engineers adjust input data to get better output using the history data and formulae. The BizDev Virtual DOE provides the optimal input data automatically in dynamic fab environments. To do this, Virtual DOE adopts BLCQ and BLCP algorithm. For BLCQ, we have to find the values of three variances based on past data. Input gain, which is the rate of input variation and output variation. Input weight, which is the weight on input variation. And output weight, which is the weight on difference between output data and the target. With the optimum combination of the variances, the BLCQ activity will offer input data within a limited range that makes output data closer to the target. BLCP first compresses many input parameters with high multicollinearity into a few components. Using the primary components, we have to find two variances related to output errors. One is shift lambda, the weight on the shift influence. The other is drift lambda, the weight on the drift influence. Using the optimum combination of these two variances, the BLCP activity can provide the optimal input data for better output by manipulating shifts and drifts. In Virtual DOE, you can pick an algorithm after considering the following points. Can it handle multi-input, multi-output? Can it handle single input, single output? Can it analyze and control drifts? Can it analyze and control shifts? Is multicollinearity between parameters high or low? Is PCA required? Click Virtual DOE and Grid Search and Training to open Data Explorer tab. In Data Explorer, you can select the input and output data from which the BLC algorithms to learn. Select your area. Select 1 day period and click Apply. To populate the parameter data table, I will select EQPID and RecipeID. Here, select the input parameters and output parameters. Click Search. For BLCQ algorithm, I will select 10 random data. To do that, right-click on the table and select Set Shuffle Count. In Set Rate window, set the training set unit as CNT or count and leave it as 10. Based on these 10 data, BLCQ algorithm will come up with the optimum variance combination in DOE processor tab. Set the exclude set unit as rate and set the ratio of the data to be ignored against the data for simulation. I will set 5 to 5. Click OK. Right-click on the table again and select Shuffle Data Select. Now you can see the 10 data are labeled as training and the rest of the data are divided in half as exclude and testing. Click DOE Processor. In DOE Processor Type Selector window, you can select BLCQ or BLCP algorithm. I will select BLCQ here. Click OK. In DOE Processor tab, you can find the optimal combination of variances for BLCQ based on the history data you chose. Select all the input and output parameters and click Setup. When Enable Optimizer option is checked, the algorithm will fine-tune and keep the input data within the range, but this may influence performance. Unchecked, the data out of range will be ignored. This will increase performance. I'll uncheck it. Input variables shows lower and upper bound. Output variables shows the target and the error limit. The range of input gain, output weight, and input weight is defined in the start and end column. In interval, we recommend setting set the scale by 10, so I'll leave it as 0.1. Click Start. The chart shows two output parameters. On the y-axis, RMSE standard deviation and the actual RMSE are shown independently. On the x-axis, the index number represents each combination of the three variances. Let's reopen the closed table. The highlighted rows correspond to the red vertical lines on the chart. You'll notice RMSE and standard deviation show the lowest values, which imply the best output data. And the combination of three variances that is responsible for the outcome. Also check the variance combination for the second parameter. Click DOE Simulator and select the tab name and then click OK. In DOE Simulator, you can simulate the variance combination. You can see the values for input gain, output weight, and input weight are imported from DOE Processor tab. Click Run Simulation. You can select an output parameter here and see its simulation chart. The black horizontal line is the target. The red dots and lines are the real data. The blue dots and lines are the simulated output by the variance combination. In the histogram chart, you can see the red real data and the blue simulated data. In Performance Report, you can learn how much the RMSE and standard deviation are improved. You can save the combination of three variances into a BLCQ model. Confirm if your area is selected and enter the model name. Click OK to save. Open Control Model to check the saved BLCQ model. Be sure to select your area and select the saved BLCQ model. If you modify parameter source, make sure to click Save. Now it's time to apply the BLCQ model to eR2R workflow. Under Flow Design menu, click Model Designer. Select your area and click Search. Right-click on a yellow workflow, which means checked out, and select Workflow Explorer Edit. In Graphical Workflow window, open Measure Data tab. In Toolbox, expand eR2R Flow. Scroll down to the part where you want to insert the BLCQ controller activity. Drag and drop the BLCQ controller. Double-click to open the activity. Select the model we saved. Click OK. Select Full Validation and save. Click OK. Right-click on the workflow and check it in. Right-click on the workflow version and release it. And right-click on it again and select Activate. Thanks for watching.